Good afternoon, everyone. I'm Alex. Some of you know me already. And I am very unoriginal with my talk titles. I sort of like keeping the same one and then swapping the content out. I got a thing for Stanley Kubrick, and that's sort of, a lot of my talks do have that reference to that. Haven't done Eyes Wide Shut yet, so stand by. Most of you do know me, so I played with the internet starting in the 90s, worked in the Bell SOC and the Olympic SOC, which is how I got to move out to this fine city. And did some consulting, co-founded Mars, which is the Mainland Advanced Research Society, and B-Sides. I was going to do some shameless promotion with B-Sides, but our tickets got sold out already, so earmuffs, you don't want to go. Oh, yes. There is a She Leads Tech, which is a SAC organization, is going to be running the first female-driven Capture the Flag at B-Sides. So if you are interested in participating in that, it's going to be a really great event, lots of learning there. So I did co-found Mirai, which is a local cybersecurity consultancy. I did teach for SANS, but I have a child on the way, so I'm taking my weekends back to donate to my child. And I did co-author this great book, contributed here, and I'm going to give a copy away. Who can guess the following? I think it's the, yes. And this is a very trolly slide. 80% of the cloud is. Does anybody have any suggestions what that is? What is 80% of the cloud? Somebody else's cloud. Maybe? Any brands out there? Okay. Any others? Okay, we're gonna get back to this. So, I started my career in Ottawa, so a town that has taken security seriously from day one, and I really cut my teeth in an environment that security was very, very important. Privacy and confidentiality were paramount. So everything we did was really about keeping things secret. I guess that's what the government likes to do. So when I moved out here, I worked on the Olympics, and security, mostly on the availability side, was the priority. But you know, security was taken seriously. But as soon as I left the warm blanket of the Olympics, I started working in the private sector and found that the world out here was very different. That there was a lot more apathy towards cybersecurity. In fact, it was typically, we're too small, we're not a target, too expensive. What? You know, like there was a lot of resistance to cybersecurity. And there, at the same time, this is around 2010 where like the ramp up of AWS started coming in, where people were just jumping into the cloud because, you know, and we can all agree that Vancouver is not a big city in terms of big enterprise and big bare metal. No one really wants to be in the data center business. And the cloud gave them this opportunity to do a lot of things that would maybe be very expensive or very a long-term investment that they weren't really interested in. And I just kept on arguing, like, are you guys crazy? Like using the cloud, putting your code or your secret details in a public server that's shared and, you know, run by anarchists? Scary. And really the objectives are, you know, two real major categories: risk management and compliance, and the security operations side. So first, you know, 2010, we were just, the Patriot Act had been out for a while at this point, and it was pretty scary, you know, what the US essentially wanted to do with anyone's data that was on a US server. And Canadians didn't like that. We sort of wanted to have our data in our own backyard, especially any governments. And privacy laws started to grow baby teeth, nothing like it is today, but there were privacy laws out there. The biggest problem I had was that, like, it's that no throat to choke, that like your data, once it's out there, you don't have any real understanding of where it is, who has access to it and whatnot. And that really scared me. From a compliance perspective, cloud initially didn't really offer any cyber security controls. It was servers right out onto the internet. Their logging was a bit of a joke. My first experience with AWS was sucking data in from the Vancouver 2010 portal. And we got logs through FTP batches, which is just rudimentary. And when security professionals were looking at the cloud, there wasn't really a one-to-one mapping of how security would be applied to the cloud. So any real staunch security professional would be like, no, we can't do that. Governments and data-sensitive organizations like the financial sector are not going to go to the cloud. Shared responsibility model, I actually purposely left the shared responsibility model slide out because every cloud presentation has that slide, and I think we've probably seen it. But it's this idea that if you're going to use cloud services, you are responsible for something. A lot of people that were moving to the cloud said, all right, we are done with responsibility. We can just use IT and everything will be their responsibility. But in fact, it is quite the opposite. We are quite responsible for parts of how we consume the cloud. And then the whole idea of the compliance inheritance that, well, AWS is PCI compliant, so if I put my software on there, I am now PCI compliant, which, yeah, you know what, some of those controls you will inherit, but not all of them. And a big problem was that people just thought they were just outsourcing all the responsibility to the cloud, and that's just not the case. Now, from the geeky side, things are really weird in a software-defined world where nothing's physical. Now, I put an asterisk there because if you do care about security a lot and you want to really protect your keys, you can get a cloud HSM, and that is actually a physical thing. That is a physical thing that you sort of own. Other than that, nothing is actually physical in terms of you being able to actually touch something in the cloud. Everything's defined as code, and IT administrators, up until recently, weren't really down with codifying their world. They really did like to manage most things through a GUI, particularly in the Windows administration world. Tools and tactics don't really work very well in the cloud, so our typical architectures didn't make a lot of sense. Layering firewall over firewall doesn't really make sense in the cloud, and the cloud didn't really provide those facilities up at first. Firewalls and IDSs are almost useless in the cloud. Now, there are some edge cases where I think firewalls do have some value in cloud, but for all intent and purposes, what we know, what is making us comfortable, didn't actually either fit in the cloud or didn't actually provide much value in the cloud. And logging is quite different. From a visibility perspective, there's a lot of things that you could be using in cloud that don't have hosts. They're not hosts in the sense that how we would track if there's an incident, how we would track, this is a host that's compromised, it's got this IP address, this host name, this MAC address. Some things in the cloud just don't have any of that. And the things that do change, and they can change every hour. So when you're starting to look at your logs that are 10 minutes old, that IP address no longer is yours. So how do you start doing incident response there? And then a notable danger of shared resources, if you are on a shared hypervisor and there's a bad guy on there, there have been some proof of concepts that allow that bad guy to jump into your VM or get some sort of data there. I would say those are mostly proof of concepts, like again, the Spectre and Meltdown are real. But there is that risk that the memory and CPU is shared, and thus there is a risk that some of your data could leak into somebody else's VM and vice versa. And there are thunderstorms. There are lots of breaches in the cloud. That is a cloud, by the way. I don't know what you guys are thinking. I'm not going to rip through all of these, but just some commonalities. So Air Canada, British Airways, and Cathay Pacific all had breaches last year, and it was because of really weak web apps and mobile apps. There was a consulting firm that had their Office 365 compromised for many months because they didn't use multi-factor authentication, so best practices not followed. Uber was compromised because they didn't really do very good development practices. The developer was using a public repo, so bad. And then two, putting hard-coded credentials in there. So the hacker found those credentials, used them to get into the account, and was in there for several months. Uber got pretty dinged by this, $148 million fine, and 20 years of privacy audits. I think that's the worst part. They can afford the $148 million. Capital One had a misconfiguration on their web application firewall. Wise had a misconfiguration on a database. I'm pretty sure that's a Mongo database, which by default is deployed without passwords. So no fines with them. What are some of the other good ones? Equifax got a $700 million fine. So things are happening in the cloud. But my argument is none of those are cloud's problem. Bad development practices, that's not a cloud problem, that's a people problem. Misconfiguration or not following standards like multi-factor authentication on administrative accounts, with Azure and Office 365, it's sort of free. You have to click a button, but you do get MFA right off the bat if you do that. So I sort of boil it down to 3 problems here. There's a cultural problem, so cloud works really well together. Dev, IT, SecOps, we've got history. Dev is really driven by getting their code out in a very timely fashion, Friday. IT is really focused on getting availability of their systems and stability and network expansion. SecOps is there just trying to manage the chaos of the other 2 organizations, sticking their fingers in various dikes. You know what I'm talking about. So, and doing security well is sort of hard. IT is complex. If you look at how we've developed IT over the last 2 decades, it's a patchwork quilt of different technologies, different regimes, different designs, and they're not very changeable. Once you've sort of built it, we sort of want to keep it going, and we'll build on top of it, hoping that we're not building a house of cards. Standards exist. Standards, I attended DEF CON last summer, and there was a GRC talk at DEF CON, which is really weird. So I had to see it. And they said, like, standards exist just to help you prevent the dumb stuff. They are not the top line, they are the bottom line. It's the baseline, it's the table stakes. And yet we're having a hard time consistently applying the table stakes in IT because of the level of complexity of our environments. And then there's a lack of process that's going to guarantee that even if we think we're following the standards, that something did change in our environment as we were discussing this, and now our compliant environment is no longer compliant. And then from a risk management perspective, we sort of suck at quantifying risk and understanding it. We are very reactive. If one of our competitors got breached, we sort of say, well, that really sucks, but that means that the attacker's not going to look at us. It's a near-miss bias. The reality is that they're not choosing, okay, we're going to go with that company and not that company. They're spraying and praying, and they're trying to get into everything. Measuring success is hard. If I'm given $1 million and I secure my company with that $1 million, did I overspend? Did I underspend? Did I not spend enough? And therein, I can't detect. Those are all legitimate problems. And total cost of ownership is sort of boring. So, we have a problem where most of the people that are making the decisions see all solutions are solved by box X. And it is a people, process, and technology problem. And by buying a firewall, you definitely need to understand that total cost of ownership. I'm a SIM guy, recovering SIM guy. And SIMs were hundreds of thousands of dollars, and that's a lot of money. But you have to realize that that's just a piece of the puzzle of how you get value out of a SIM. And it's a very people and process-driven technology. So, there's a monthly hacker social that I like to hang out in, and I kept on, butting heads with everyone that was going to cloud, just saying, like, you're crazy to do so. And I started losing the argument, really. And then it just clicked that, like, maybe cloud is actually more secure, and maybe can actually be more secure than typical IT environments. So cloud service providers, they got secure. They started realizing that if they wanted big business involved, they had to actually start bringing security in, both from being compliant, following standards, but also starting to ramp up security as a service offerings within the cloud. And that's really what fascinates me, and because of when I was a kid, I was a Lego maniac, was that cloud is actually just a bunch of Lego pieces that are very well interoperable. They definitely will connect to each other and interact with each other. So you can say, yes, I have a web server and I want it to talk to this other application. Well, you need something to talk in between. Well, you could create some sort of communication path over networks, which is old school, or you could use a message bus that gives you a lot more reliability and throughput. Again, one of many examples. Now there's this benefit of decoupling. So the idea that if we can manage less of the things, then we can do better at the things we still have to manage. And the idea of, if we look at the OSI layer, the layer 1, electricity, layer 2, the data, layer 3, the network, etc., those aren't very important to our business, but we need them to support the business. Well, layer 1 could also be argued as that's HVAC, power management, and stuff like that. Those are all really boring. We don't want to do them. By going to the cloud, we're able to outsource the responsibility of keeping your data cool, keeping it powered and highly redundant power, et cetera. And the same thing goes for networking and higher layers up. again, like there is networking in the cloud, but it's just there, not in the sense that we use networking. It does provide some interconnectivity, but all in all, that is a representation of what we recognize as networking. Now, the codification of IT is really cool. It's it's essentially a text file can describe your data center. And that is really hard to do in a traditional data center, and yet almost mandatory in a cloud environment. And this allows us to do the standardization, saying that this is how our IT environment is going to look, this is the VLANs we're going to have, this is where the servers are going. We can all describe that through text file. Awesome. The next value is that we can now version it so that we have something running, and then we can make version 2, spin it up, start seeing if it works, maybe spray a little bit of user traffic to it and see if it works. And if it doesn't work, then we kill it, rejig the code, and redeploy. We can do that without creating massive outages, which I think in the traditional IT environment, we're creating every time we try to do a change in production. The idea of queryable infrastructure really is interesting. So this is the idea, that there's towers around here that all have data centers. And I always challenge the IT managers, can you tell me an accurate depiction of what's in your data center? And I'll give you 4 hours to do it. But I want 100% accuracy. I don't think any data center manager or CTO could actually do that. Yet, while I was explaining it to you, I could do that in cloud. I could get a very 100% accurate depiction of the hosts I have, the assets I have that are non-hosty, and even start digging into the different layers of software that I have in there. This allows us to be able to easily audit for compliance in real time, which is just a power that we just can't grasp in traditional IT. And lastly, automation and orchestration. So the IT side of being able to spin up your data center within seconds from an instruction set, which is a text file, but also that automation piece. And for me, it's really about incident response. And I've got a basic use case that you can leverage the automation pieces to really help your incident response team manage incidents at scale. So this is the buzzword slide. And digital transformation for me was pretty much a buzzword, but I started to get an understanding of why it is actually important, because we're sort of at a cusp of how consumers are consuming our services at business, how our employees are consuming it. And digital transformation is taking the existing business systems and business logic and rolling it into a new paradigm, which may be cloud. So what are some of the drivers? Well, the obvious ones are going to be agility, efficiency, synergy, and cost savings. I had to put some more buzzwords in there. But when I sort of looked at it, I was like, okay, well, business wants to be more efficient and cost saving. That's why they're going to the cloud. But really, it's transformation by gunpoint by these digital natives, which is the nicer term for millennials. And when we look at that, like, who are digital natives? And those are going to be the consumers. But those are also going to be your employees. If you can't sort of align to how business operates, generally speaking, in terms of applications, you're going to have a hard time retaining talent because you're forcing them to use a technology that is not tangible for them in their next step in their career. So appification, putting things through web apps, mobile apps, and being able to enable staff to be productive, but also use technologies they like. A really good example I heard from a podcast a while back was, like, websites were marketing tools up until fairly recently. But now they are the business. And a really good example of that is QuickBooks. It's an accounting software that you used to go to the website to download their thick client, and then you would do accounting with it. Now their website is the business. It is the majority of the business that they're acquiring with the SMB and SME market. So now they need to protect that application, because it's not only that they don't want to breach there, but they also definitely do not want to breach because all the data is behind that one application. So what does it look like? These are some of the sayings I've seen. We are now agile. We are now a technology company. That's an interesting one, because you come across like companies that you would say, you're not a technology company, but now non-technology companies are realizing the power of data analytics, and I've heard of this ML and AI stuff that's going to enable them to get more efficiencies out of their business. The most interesting one is, we want to get out of the data center business. They sort of realized that running a bunch of bare metal and all the fun and pain that goes with it is not really enabling the business moving forward. We are developing and customizing code. So everyone is now becoming a dev shop. So you weren't a tech company, now you're a tech company, now you're a dev shop. So there's some major aggressive changes happening in the business, and there's some risks. So first, raise your hand if your employees get credit cards. Okay, so you're all in the cloud. You just may or may not know it. So a lot of companies are already in the cloud to some extent, whether it is a SaaS that HR signed up for, or marketing, or some dev team did start spinning up a small environment. The challenges are going to be dealing with some of the existing systems. So you have business systems, you need to move it into the cloud. So those legacy systems, which are systems that should be replaced, and then a friend of mine coined heritage technologies, which are things that are so old they can't be replaced. And so you have to maintain them. So those are likely things that will never go to the cloud. But a lot of organizations do the lift and shift model, which is I have 10 servers in my data center, so I need 10 servers in the cloud. And that's really not how the cloud works. In terms of like a net benefit of getting a lot of power out of the cloud, moving your 10 servers over is not good. There's a good saying that if you suck at security in the data center, you're going to really suck at security in the cloud. Because you're going to bring all your bad habits that we're trying to get rid of into the cloud. As I said, a lot of the normal security things that we've been used to in the network security world are somewhat irrelevant. There's only a few edge cases where I think getting a virtual Palo Alto or a Fortinet or Cisco, not picking on any brand in particular, into the cloud is just a $5,000 a month exercise to feel warm and fuzzy. It doesn't necessarily provide much value as far as I'm concerned. And then, adopters, the ones that are adopting it aren't really communicating to the company in terms of are we introducing any risk to the organization? Now, this world of appification, because everything is now going from a thick desktop client to the web browser, security doesn't really understand layer 7 very well. So we sort of stay away from it. I remember looking at a WAF 10 years ago, looking at those rules and be like, whoa, I can't handle looking at this code. It's horrendous. Because it wasn't really native to us. We understood TCP/IP, that was good, but any of those layers above that were very challenging. Devs have bad habits. I don't think that they're out to make the world insecure. But if it's make the software secure or get the code pushed on time, we know where we're going. A journey that I've been going through, a sub-journey, is secure software development. And that is a process, and it does require an adjustment in an application development velocity that we need to be able to push up to the business to say, yeah, we're going to slow things down so we can do things better. It's a hard sell, but we need to communicate that a bug in production is about 30 times more expensive than a bug at design, and we need to be able to communicate that better. Now, a lot of companies are becoming dev shops. So who can tell me what a 0 day is? Kevin?
Where there's a vulnerability but a patch does not exist.
Exactly. So Microsoft doesn't know that there's a vulnerability and it's being actively exploited by the bad guys. Typically, this is really bad guys, state-sponsored cyber warfare type stuff. And it is pretty scary that there could be a 0 day in your application. But I would say Microsoft's getting pretty good at being really managing the risk of having a Microsoft server sitting on the internet and having a 0 day in it. But if you are a dev shop now, everyone gets 0 days. And the reality is that when every company starts rolling their own software and isn't doing a secure software development platform in terms of implementing security at the architecture level, design level, doing good coding practices, doing good testing, then everyone will have a 0 day. And because our web applications are now the gatekeepers behind the big data store of all the sensitive stuff, it's a bit of a scary world, and the digital transformation of these organizations is really going to struggle. And most third-party SaaS sucks. I've got a good story. I think I'll whip that out in a bit. Lastly, Verizon DB Report, they do one every spring, so this one's from last spring. Major commonality, web apps are in the top 3 attack patterns of every industry except for public sector. And the only reason they're not in public sector is because public sector obviously has an espionage problem. And they don't use modern day applications. A lot of times they're a little bit behind. But it's a 3-to-1 ratio of web applications compared to all other attacks. So, there's a problem. So remember this. So what is 80% of cloud? Sorry?
Interconnected devices.
In terms of what is cloud? Well, I would say that there's definitely a lot of connectivity in the cloud. This is a trolley question. Everyone's, sorry?
Scalability.
No, I'm looking for, I'm trolling you to say AWS is 80% of cloud. Nope, it's SaaS. 80% of how we consume cloud is not AWS or Azure, it's SaaS. Now I know you're going to say, well, all that SaaS is on AWS, and I totally agree, it is on AWS and a little bit of Azure and GCP. But who do you have your contract with? Do you have it with AWS, who's pretty good at security, or do you have it with Ma and Pa SaaSco, who may not understand security very well? And my company was using this proposal software, and we were trying to support a Canadian company. There were some idiosyncrasies with it. Copy and paste didn't really work very well. And then one day, and again, not going out of our way to do this, we decided to fiddle with the URL a little bit, and instantly we're in somebody else's account. And then, no, that can't be. And we changed another little character in another account. So we ended up reaching out to this company and saying, there's a problem. First they blew us off saying, yeah, but no one would ever be able to do that. Hold my beer. But the reality is that it was a link to share outbound to clients, and it was a random string. The problem is it wasn't random. It was padded. It was 16 characters, 10 of which were the same character. And then the 6 were not random, it was inversely sequential. So we just had to start guessing that, okay, if it was B before, it'll be A now. And so we did find out that they also have a client called Mirai Marketing. Lots of solar panel companies. It was bad. So we reported it to them. They put a fix in. We wouldn't agree that that fix was the right way because there's this concept of hash collisions that they were struggling with. But a few months ago, they reached out saying, we're adding a bunch new features to the application, and we're charging you double now. I was like, whoa, that's a lot of money. And I said, well, have you fixed copy and paste yet? Because if you're adding all these features, and that's the reality is that, SaaSes are very aggressive to grow and add new features. They're not necessarily building security in and taking care of security. And when we're starting to do the digital transformation thing and outsourcing a lot of what is in our data center into a SaaS provider, we now need to start working with that SaaS provider to make sure that they are managing the risk accordingly and supporting our need to manage risk. And the reality was we couldn't deal with this client anymore, and we left them. Or sorry, not client, SaaS. So can cloud enable better risk management? Let's talk about it. Okay, so first, are cloud service providers any good at security? So the tier ones, that's going to be the AWS's, Azure, and maybe GCP. And I only say that because they've sort of told the US government to pound sand when it comes to their requirements. But I would actually argue that they're probably doing security better than us because they have a major incentive to do so. If we have a security breach in our companies, somebody's head may roll, somebody may go into early retirement, but the company will still exist. But if AWS has a major breach that is a problem with AWS itself and not how we have configured it, S3 buckets, they're not going to exist because there's going to be a major exodus of people leaving it because it's totally untrusted. Tier 1 cloud service providers are perpetually audited under a ridiculous amount of standards that they are following. So they've built in a program where they're automatically being able to detect when a change in compliance happens. Try doing that in a traditional data center. It's impossible. But don't trust, let's verify. So don't assume they're doing the right thing. Even with AWS, I would say that you should do your due diligence, and especially with SaaS. Check out their privacy page, check out their security page, then copy and paste their security page into Google and see where they copied it from. Very important. Read through their reports, their audit findings and tests and white papers and all that stuff, and just make an informed decision, because once you start using these tools, you're putting yourself at a risk because you lose that control. But a note, cloud service providers will not own all the risk. So depending on if it's an infrastructure as a service, platform as a service, SaaS, your roles and responsibility are very important. The idea is that if your account gets compromised, do you consider that a breach? Yes, no? Does AWS think it's a breach? No, they don't see it as a breach. They see it as an increase in how much you're going to pay, but that's not really a breach to them. So they're not going to react to it like we are. And of course, the shared responsibility model goes into that in detail. Okay, so I'm going to speak a little bit faster because I'm a little bit behind, but things I really like about it is like this one ring to rule them all. So generally speaking, in cloud, all the modules within the cloud are talking on this management backplane. And that's where your commands go to manage all the devices. That's where all the logs go. It's a single point that all things connect to. And it's also out of band, so the hackers shouldn't be getting in there to fiddle. And we're interacting with that typically through either the web interface or the API, which is one and the same, but for all intent purposes, it looks different for us. I also think their identity and access management capabilities way better than what we see in the traditional Active Directory world, in terms of that it's both authenticating us as humans, but also assets, and the policies are really granular and can be provisioned on a time basis. So yes, you can be an administrator, but only for 5 minutes, right? Like those are really great features that are fairly native in cloud and sort of hard to implement without millions of dollars of other software in your IT environment. And also I think that, being a SIM person, it's always been like, we're gonna get about 90% of our logs. We're never gonna get all the logs, either because they're just too hard to get or it's too expensive to collect them all. Whereas cloud does log all the interactions, administrative interactions and whatnot within the environment natively. And that's really convenient for doing incident response, doing understanding compliance, et cetera. Now don't be fooled. That logging capability is to bill you, but the net benefit is that you get to see your logs as well. So for some prevention capabilities, when we start looking at IT infrastructure, cloud allows us to start going out in the out-of-box approach. There's a couple different architectures. Tiered multi-account architecture is really cool in terms of like really creating ultra isolation. So each Amazon account, as an example, is very isolated from the other. So you can actually have a production and a development environment that are actually very isolated from each other. Some other clever mechanisms is starting to design your applications in a microservices approach. That's really looking at, I have an application that does all these things. Is there a way that we don't have to use Windows or Linux servers to do them? And microservices are one of those mechanisms to do so. Microsegmentation. So it's 2020, and I still have clients that are bickering with me why network segmentation is not important to them. And for organizations that have sensitive data, financial transactions, et cetera, I do believe that we want to separate the marketing team from the ATM network. I think that's important. And I think that's also the standard says it's important. Yet we do still have that problem. And the resistance isn't that they don't think it's of value, it's just that the cost of it is so high. To re-architect your network, you're talking hundreds of thousands of dollars. It's expensive, and likely you're going to be going to the cloud anyways. Cloud offers not network segmentation, micro segmentation. So host to host definitions of what can talk to what. That moves the needle way forward. So even if a system does get compromised, you're not going to have this pivoting problem where they're in your network and you can't see them and they're just jumping around. I mentioned that before, refactoring. Again, if you've got a web server and then a database server and you want to get out of the database administration business, awesome. So get rid of that database server and use a database as a service offering, which is a PaaS offering. And all of a sudden you've got the high reliability of the database you've always dreamed of without having to ever administrate it. And I think that's a major benefit. Databases aren't very fun to manage. Bolting onto the infrastructure as code is the security as code piece. That it's defining what good security looks like in the environment, and that can be anything from defining what operating system images are able to be used, what configurations are authorized, and we start looking at that from like just enabling, so for the developers, enabling the developers to do the right thing without them having to think about security. And this comes down to essentially defining what we call paved roads, which is this is the images that you're allowed to use. This is how you can this is a good configuration of a Mongo database. We're going to put passwords on it. We're not going to let it be publicly exposed. And then we'll leverage guardrails as like sort of compliance enforcement mechanisms in there as well. Embracing the DevOps method. So one of the terms I really like is this concept of immutable systems or sterile environments, where you do not do any changes in production, but rather you create a second version of your environment, make sure it goes through all your tests, spray a little user traffic, does it work, and then you cut over to version 2. You'll never have an outage. I think if you've worked in IT long enough, you know that making a change in production is rolling the dice and is a weekend ruiner. So this is a whole idea of being able to do so. And same thing with patching. That, I'm not saying do not patch. Patching is very important, but patch in version 2 and then push that to production and then kill the other one. Now, if you have immutable systems, you can also reduce the attack surface. Why do you need SSH and RDP on a system that never changes, right? So if you remove those means of an attacker being able to exploit your system, you're reducing the attack surface, reducing risk. Okay, so detection capabilities, this is too markety. So there are a lot of cool cloud native capabilities. Guard Duty and Detective or Azure Advanced Threats is essentially an IDS that looks at network. It also looks at how people are interacting with your environment. AWS Inspector is a poor man's Nessus. Config is a configuration monitoring tool, but there's way better open source tools out there in my opinion. Macy finds sensitive data, PCI data, stuff like that. Also is a data loss prevention solution. Security Hub and Azure Sentinel or SIMLite. I actually got to play the Sentinel lately, and that is super cool. Definitely, if you are in the Azure world, Sentinel for a price is really fun to play with. And there's a lot of free as well as pay third-party solutions, because again, if the entire environment is running off this control backplane, which has a common language to interact with it, now you can start scripting and auditing the environment. So a lot of, again, third-party open source or pay-to-play applications and services are out there to really help you get to the next level of security maturity in your cloud. And then logs, there's lots of log capabilities in there. All right, so all the juice, half the squeeze, how we can do security better. So I am a big fan of critical security controls. It doesn't have a governance side to it, but for organizations that need to really know tactically where they need to apply security, it's a really good tool. So top 6 is like just the table stakes to go by, but it's in order of 1 through 20, 1 being the most important, 20 being the slightly less important. So 1 and 2 is asset management, hardware and software, and as I said, that is really a challenge. When I do audits against clients that do that, even though this is the most important control, it's also the least well implemented. It's where most organizations are pretty low in maturity with that, because again, it's a patchwork quilt. There's no commonality with your assets, so you may have a spreadsheet for 20% of it, you may have a CMDB tracking 80%, but like you're not having a very consistent view. With the queryable infrastructure built in agents, like you can have total visibility of what's in your environment. Vulnerability management, very important. There's some native capabilities, as I mentioned. A lot of automated patching capabilities, but you could just like say, I'm not going to be in the operating system administration business anymore, and reduce your vulnerability management responsibility about 90%. And that's if you go with a platform as a service, you're no longer responsible for the patching of the operating system below your responsibility layer. As I mentioned, administrative control management. So, I'm pleased to say that most end users aren't administrators on their desktop anymore. So that is, we're moving in the right direction. But administrative controls from an infrastructure perspective is also still pretty challenging. AWS more so has really just sort of done a next generation approach to it, and it allows for very granular privilege delegation and temporary assignment of privilege escalation, and very easy to audit. Secure configuration, pre-built images that either your team can build. There's a marketplace. I'll put an asterisk there because there is a lot of garbage on the marketplace, but there is some good stuff on there that will say this is what a pre-built Nessus server looks like. This is what a pre-built F5 looks like, or whatnot. But there is Microsoft researcher did a really good analysis on the amount of bad on their marketplace. You can do a lot of automated hardening. And refactoring to pass, and then lastly, logging and monitoring. Again, everything's logged, and it is SIM compatible. I put process under there. Process is very important because again, this is where we're starting to look at. There's a GUI component to this, but you've got to get really comfortable with standardizing how you're, writing your infrastructure's code, your build books, essentially. So let's talk about a couple cool use cases. Whoa. Got a few minutes here. Okay, so an automated blacklist. So as you're detecting threats hitting your environment, you want to start automatically tracking these threats. So dynamically blocking those users as they're hitting. So again, this can be a native or third-party web application. I would say the web application, well, I do say most firewalls are sort of low end. The web application piece does actually have value, especially if you are a very customized web application. But most CSPs do have a fairly rudimentary one. AWS has guard duty, and then also something I really try to encourage with the dev teams is really build in detection mechanisms in the application. Make the application aware that there is, that the application can, make you aware that, hey, something's wrong. This user's not interacting the right way, because that's really important. And then you'll be able to leverage the automation capabilities to start adding IPs to Blockless that then get automatically updated to your firewalls, and also maybe send it to a threat feed so that your other peers in the industry are actually starting to share, which I think is pretty clever. Compliance violations. So this guy is both drinking, talking on a cell phone, eating, and smoking. Whoa. So it's this idea that we can detect policy violations in real time, which again is just not something that is very easy in a traditional IT environment. So again, CloudTrail is a really good log source for this, and then there's other third-party monitoring tools so that both look at your your CloudTrail logs, but also will be doing periodic querying of your environment and looking for anomalous configuration changes. And then you can trigger suspending that person's account, suspending the actual device. So as an example, dev spins up production MongoDB on public IP. That could be very quickly detected and then turned down, notify the Security Operations Center, and then delete the device after a few days. Compromise host. So this is this incident response, and again, there's some really cool use cases. I can't really put into a whole presentation. We focus on that, but it's the idea of wanting to do forensics in the cloud. So doing detecting something has gone wrong, and then being able to start acquiring some data so that you can do forensics on that. So with the immutable systems, no incident response required. Delete it and then move on. Spin up a new box. You're good. But on the more traditional systems, you want to be able to trigger automatically quarantining that system, moving it into a quarantine environment, being able to do more analysis, and that can be anything from doing a hard drive image, memory dump, starting to look what is it trying to connect out to, and starting to look at those logs without turning the system off, which could trigger the malware to self-destruct. Also, that could also trigger other automated playbooks. That's really cool. So to wrap it up, I think cloud is a really big opportunity to have a greenfield approach to IT and do things really cool and next generation. And I was really against this stuff. I've been really excited about it, and I love playing with this cloud because it is the Lego bricks of IT as far as I'm concerned. But I would say, there's a good way and a bad way of doing it. The people that do the lift and shift are likely going to have higher interest rates on their tech debt. So what I would say is assessing risk and having a risk assessment framework of how you make decisions, very critical, and I'm a security person, so I have to say that. Doing some threat modeling will help you really, visualize your environment and understand where attacks will be, define and enforce those standards, and there are lots of third-party tools out there, but smaller shops can definitely roll it themselves. It's just scripts, and you can just iteratively be improving more and more of your playbooks of how you are detecting policy violations. And automate as much as you can, because I think the automation piece is the biggest and most awesome piece. So shameless plugs, my day job, I work at Mirai, so we translate governance, risk management, and compliance, the why, into the security operations, cloud, and application how. I did want to do a shameless plug on B-sides, but sold out, sorry. I'm gonna talk to the organizer and see if we can open up a few more too. So get on the wait list is the best advice I can give. And thank you. And any questions? You have 30 seconds. No?
Not a question, but I think the way I sell cloud from my organization, or there's the sphere of cloud, the way I sell it is, it's actually an opportunity for a fresh start to do security better.
Oh yeah.
To move away from the bad habits, the traditional systems, and now we can actually re-architect everything from scratch.
Amen.
I think that is the best way.
Again, I do not recommend moving anything from your data center in directly. It's really about moving something, moving the business logic and whatnot in, but not racing to the cloud. And again, unfortunately, a lot of clients that I've had have like, well, our data center closes in 3 months, so and like
a lot of people say, oh, but you hear about all these breaches at Amazon, and I always have to say, it's actually not Amazon. You'll find there's a security guy who didn't secure a bucket, for example, or let something open. It's nothing to do with Amazon.
Robert, a security guy would never leave an S3 bucket open, but Dev would. Thank you very much, everyone.